Wave division multiplexing, or WDM. WDM is a technology in fiber optic communications which multiplexes a number of optical carrier signals onto a single optical fiber by using different wavelengths. This technique enables bidirectional communications over one strand of fiber as well as multiplication of capacity. In optical fiber communication, the signal corresponding to a channel is translated to an optical frequency, generally expressed in wavelength, and transmitted. This optical frequency is expressed by its equivalent wavelength and denoted by lambda. Instead of transmitting only one signal on the fiber, if two or more signals are sent on the same fiber at different frequencies or wavelengths, it is called WDM. The term wave division multiplexing is commonly applied to optical carrier, which is typically described by its wavelength, whereas frequency division multiplexing typically applies to a radio carrier, which is more often described by frequency. Time division multiplexing, or TDM. It is a communication process that transmits two or more streaming digital signals over a common channel. In TDM, incoming signals are divided into equal fixed length time slots. After multiplexing, the signals are transmitted over a shared medium and reassembled into their original format after demultiplexing. Time slot selection is directly proportional to overall system efficiency. TDM is also known as a digital circuit switch. In TDM, each logical channel is allocated a time slot to transmit over a shared physical channel. In TDM, the digital data corresponding to different sources is combined and transmitted over the medium. The multiplexer collects the data from each source, and the combined bit stream is sent over the medium. The demultiplexer separates the data corresponding to the individual sources. Frequency division multiplexing, or FDM. It is a technique of multiplexing, which means combining more than one signal over a shared medium. In FDM, signals of different frequencies are combined for concurrent transmission. The total bandwidth in FDM is divided to a set of frequency bands that don't overlap. Each of these bands is a carrier of a different signal that is generated and modulated by one of the sending devices. The frequency bands are separated from one another by strips of unused frequencies called guard bands to prevent overlapping of signals. FDM is an analog process. It can be applied when the bandwidth of a link in hertz is greater than the combined bandwidths of the signal to be transmitted. FDM works by transmitting all of the signals along the same high-speed link simultaneously. In FDM, the communication channel is divided into different frequency bands, and each band carries a signal corresponding to one source. The modulated signals are combined together using a multiplexer or MUX in the sending end. The combined signal is transmitted over the communication channel, thus allowing multiple independent data streams to be transmitted simultaneously. At the receiving end, the individual signals are extracted from the combined signal by the process of demultiplexing or demux. FDM is used in cable TV transmission, where signals corresponding to different TV channels are multiplexed and sent through the cable. At the TV receiver, by applying the filter, a particular channel's signal can be viewed. Radio and TV transmission are also done using FDM, where each broadcasting station is given a small band in the frequency spectrum. The center frequency of this band is known as the carrier frequency.